Hi there. In the last video we have looked at the algorithm of insertion in single linked list. Now in this video we will implement that algorithm using Python programming language. So in the lecture of creation of single linked list, we have created node class and we have created single linked list over here. Here just I added an extra function over here to make our single linked list printable. So we can use this expression over here, we can print out our single linked list. So we will need this after creating our insertion method over here. So here I will create a new method for insertion. We will create this method by using the algorithm that we have looked in previous lecture. So if you haven't watched the previous lecture, I advise you to go back and watch it, because without knowing this algorithm it's difficult to write this code over here. So according to our algorithm, we will create a method which will take two parameters. So here inside this single linked list class, I'll create a method called insert to single linked list. So here I will create method insert single linked list, and here as a parameter it will take itself as a parameter, then value and location. So the first step in our algorithm is to create new node. So we will create a new node based node class over here. So our new node will be like this. We will use node class. So this, we are creating an empty node over here. Then we are initializing a value to this node. So to initialize a value to this node, we just take the parameter from here and we will put inside this node class. So by using this, we are creating a new node and initializing a value to it. This is the first step in our algorithm. Then the next step is we are checking if head value is null or not. If head value is null, it means that we don't have any node in our single linked list. So we are creating our first node by creating reference to head and tail. So here we will put if condition if self.head is none. Then as I said, this means that we don't have any node in our list. So we will reference our head to this node and tail to this node. So it will be like this. Head equals to new node, and our tail also will be referenced to this node over here. So by doing this, we are adding the first node in our single linked list. So this single linked list over here will consist of only one node. So the next step in our algorithm is we are checking the location parameter from here. So in this case, if the location is 0, it means that we want to insert an element at the beginning of single linked list. So here I will put like this, else. Inside else statement, I will put another if condition which will check our location parameter. So if it is equal to 0, it means that we are inserting an element at the beginning of single linked list. So how we are inserting an element at the beginning of single linked list? So we know from our algorithm that here first we are setting the next reference of this newly created node over here to the head, then head reference to this new node. So here I will do like this, new node.next equals self head. So you might be interested that why we are putting new nodes next to the self head, because so here head stores first node's physical location. So we are setting the new node's next reference to first node's physical location. Then we are updating head with new node's physical location. So we will put like this, head equals new node. So with these two lines of code, we are adding new node at the beginning of single linked list. Then the next step is to add an element at the end of single linked list. In this case, we are checking location parameter again, else if location equals 1. In this case, it means that we are inserting an element at the end of single linked list. So to insert a node at the end of single linked list, first we need to set new node's next reference to null, because we know that the last element's next reference is null in case of single linked list. So here we are setting it null. Then the next step is we need to set last node to reference to this node. So last node's next reference will be physical location of new node. So in this case, to access last node, we will use tail. So we know that tail stores the physical location of last node. So if we access the next value of tail, it means that we are accessing the next reference of last node. So I will set it to new node. So by doing this, we are creating link between last node and new node. Then at the end, we have to create a reference between tail and new node. So in this case, it will be self-tail equals new node. So with these 3 lines of code, we are adding new node at the end of single linked list. Then the last case in our algorithm is to add an element in the middle of single linked list. In this case, I'll put else over here. Then in this case, we need to traverse through single linked list and find the location that we are going to insert our element and do certain updates to reference values. Here, first I will create a temp node which will take the value of head because we need to start from head to traverse. So I'll create another variable which is index, which will help us for looping. Then inside while loop, while index less than location -1, then we will assign temp node.next, which means that it will traverse through single linked list and every time it will take the value of next node in the list. So it will traverse till index reach the location -1. So here in each step I will add 1 to index 1. So we are traversing one element in each step. By doing this, we are finding the current element. That's why we put location -1 over here. We need to identify next element in the list to insert this node between current and next node. So to identify next node in the list, I'll create a node over here, next node. We know that if the temp node is the current node, then the next node will be temp node's next value. Then to insert a node between this node, we need to set current node's next reference to new node. So we know that current node is temp node, so temp node's next reference will be new node, and then new node's next reference will be next node. Next node. So by doing this, we are inserting this new node between temp node and next node, which is temp node is our current node and the next node is the next node as it seems from its name. So with this, we are completing our insertion function. First, we created a new node, then we checked that if there is any node or not. If there is not any node, we are inserting it straight away and creating reference from head to this node and from tail to this node. Then we have 3 cases. We are inserting an element at the beginning of single linked list, then at the end of single linked list, then in the middle of single linked list. So by using this insert method, we can insert an element in single linked list in 3 different ways. So let's check our function that if it is working properly. So we know that before we created a single linked list like this, in this case we don't have any element in this single linked list. So let's try to add first element over here. So to call this function over here, we know that it's located inside this class. So we create a reference to this class. So by writing the single linked list dot, then we can call this method over here. So I'll put, for example, first value is 1. Then as a location, we know that we don't have anything over here. We can put anything we want. I'll put 1. So let's run our code. We see that this node, which has the value of 1, is inserted in our single linked list. So if I add, for example, another one, here I'm putting 1, which will add it at the end of this single linked list. So let me change the value over here. Let's add few. Three and 4. Then let's run our code. You see that here we receive an error. So I reviewed our code. I saw that we did a mistake over here. Inside, in this else condition, we need to put none over here. I just mistakenly mistyped it. So it should be none, not null. So if I save it and run our code, you see that it inserted 1, 2, 3, 4 nodes over here. So every time it inserted at the end of this node over here. Let's try, for example, our first case, to insert an element at the beginning of single linked list. So I'll copy this from here and put it separately. And here, for example, I want to insert 0 at the beginning of this single linked list. The value is 0 and the location is 0, which means that it should insert at the beginning of single linked list. So here, if I run our code, you see that 0 is inserted at the beginning of single linked list. So here we tested 1. If we put 1, it's adding at the end of single linked list. Then the third case is we need to add in the middle. So for example, if I run our code for different case, if I put, for example, 3 over here and run our code, you see that 0 is inserted after the third element. So this is first element, this is second, this is third. So after third element, we are inserting 0 over here. If I put, for example, 4 here, it will be inserted after 3. You see that our method is working perfect. So this is how we are implementing insert method in single linked list. So you might be interested what is time and space complexity for this method over here. So let's start from the beginning. So here we are creating new node, which is constant time operation. Then we are continuing to check in if condition head value, which is O1 time complexity also. These assignments over here also O1 time complexity. Then this if condition and these assignments over here, all of them are constant time operation. And if we continue to the next if, inside next if we see that we have if condition and assignments over here. We are just updating the values which are constant time operation. In the else statement, we see that we are looping through single linked list. And we know that looping operation takes O(n) time complexity. So this part over here in else condition is O(n) time complexity. And these assignments over here is O1 time complexity. So if we combine everything here, we know that non-dominant terms will be eliminated. So in our case, O1 time complexities are non-dominant terms. So the time complexity for inserting an element to the single linked list is O(n). Now you might be interested in what is space complexity. The space complexity is O1 because here we are just creating two nodes. The first node is new node over here and the second node is temporary node over here. So that's why the space complexity is O1. So this is all for this lecture. In this lecture we have developed a method which can be used to insert an element in single linked list in 3 different ways. So see you in the next lecture.